Very good morning to all the participants. So we are back with the fourth session of our international webinar series. We have received a very good response from participants yesterday. The interactive session was also quite good. So we expect the same today also. The participants can put forward their questions during the session on the comment box, and we will take up those to the speakers at the end of the session. Okay, and the feedback link will be provided just like yesterday. Feedback link will be provided at the end of the lecture. Okay, so do not worry for the feedback link. We will provide that. Today's speaker is Mr. Joydeep Das, who is from TCS, Florida, USA. So I am bringing him on screen now. Hello, sir. You are on screen now.
Okay. Good morning, good evening, everyone, wherever you are.
So, sir is from America, and right now at his place, I think it's around 11:30 p.m. Yeah. So I hope sir had his dinner.
Yeah, dinner.
Okay. So it's going to be a good session now. So I am bringing on screen head of the Department of Mathematics, Dr. Biplab Chaudhary. Hello, sir.
Hello.
Yeah.
Good morning.
So you are on screen now. And we have yesterday's speaker, Dr. Anirban Roy, with us. Hello, Anirban, sir. I think, okay, he will be available after some time. Okay, so I'd like to request my student, Shubham Roy, to introduce the speaker. Yeah, to read out his biodata. Yeah, Shubham, you can go ahead.
Good morning to one and all present over here. This is Shubham Roy from the 6th semester of the Department of Mathematics, Gurucharan College, Silchar. I'm really very grateful to have this opportunity to introduce our resource person, Mr. Joydeep Das. Sir, I heartily welcome you to today's session. So, Mr. Joydeep Das is originally from Silchar, Assam, and he completed his graduation with mathematics honors from Gurucharan College, Silchar, and post-graduation in computer application from Bangalore University. So he has been working in IT industry from past 17 years, and currently he is working in Tata consultancy service for past 15 years. And he has experience of working with diverse business units like banking, insurance, high-tech, manufacturing, media and information science, telecommunication, utilities, healthcare, retail, corporate and government clients. He worked with clients in different countries like India, Malaysia, Japan, Netherlands, Germany, Sweden, and United States. Currently, he is staying in Florida, USA. Sir will be talking to us on digital transformation, which is certainly a very interesting topic. Now, I'd like to request Devashish sir to kindly continue the session.
Thank you, Shubham. So I'm putting you backstage now. Okay, so we shall begin the session soon. Joydeep sir will be talking about digital transformation. So for this webinar, we decided to bring speakers from diverse backgrounds. So yesterday there were talks on weather forecasting, then tiling and tessellation from of plane. So there were people from actually mathematics background, means who are working on mathematics or mathematics faculty members. There were people who were working on a different discipline or interdisciplinary areas. And today we have somebody from the industry itself, TCS. So we are eager to listen to what he has to say on digital transformation. And I hope it will be a very interesting session. So it's over to Mr. Joydeep Das for his session. So he will share his screen. Yeah, I'll just, yeah, it's already shared, right? Okay, yeah, this is the one. Yeah, your screen is visible, sir.
Okay, so it's all mine now?
Yeah. So you have 1 hour. After that, we'll have the interactive session.
Sure.
So I'm, yeah. So the participants can see your slides. Yeah, I think it's not in full screen. Yeah. Okay. Yeah, it's okay. So you can hide that pop-up thing here. Yeah. So participants can see your slide and they can see you also. I am going backstage now.
All right. So fine. Hello, everyone. So you already know about me. Thanks, Shubham, for a nice introduction. And before beginning, let me first give a special thanks to the organization committee, especially the HOD sir, Biplop Nath, who was also my uh, professor when I was doing my graduation in Guru Charan College, Silchar, in the year 98-99 time. And also, last but not the least, Mr. Devashish. He actually did a wonderful job and doing a wonderful job in fact, and coordinating with us in different time zones, late in IST hours and all. So many thanks. And also, it's a privilege for me to talk in this kind of stage and forum. And so I'm really very thankful to all of you. All right, so let's begin. And I have this as the introductory slide of digital transformation. So the topic, as you already know, the digital transformation. So before going to the topic, let me first tell you what you can expect from today's session. So you might already attended the past sessions, which some very good speakers across across the geography, like they already talked you like and shared their research works and all. Okay, so I think it's a very good storyline that first you got the uh, the mathematics part of it, and now today you are seeing where actually it's really getting used and what are the implications. And so it's a good storyline. Now, whoever organized that, the sequence is good job. So to start with that, this is an abstract of the digital transformation. So you will get to know a lot of digital and on both digitization and digitalizations things, and the transformation basically, how it's happening from past many decades and where we are heading up to, and what, and more precisely, since you all are from mathematics background and this forum is also a mathematics, so the usage of mathematics uh, in the industry sectors and where we are heading up to, you'll get a very good idea. So this transformations, basically the digital transformations, it's what is that actually? So it's not about the digitalizations of something, or just talking about the technologies. Okay, we know machine learning, artificial intelligence, data science, and all. So jumbled up of all the jargons and buzzwords. Is it a trend? It's not actually. It's the digital transformation where industries are going to is an overall shift to from present to the future model, how you will do the business. So I'll give you a brief definition. So before that, I just wanted to read it out for you. The transformative power of digital solution has been topic of much discussion in recent times. You might already, this is not a new word. You might have already very much well versed with this digital things, whether it's a digital clock or digitalizations or digital transformation. So digital is a very common word. As technology continues its rapid increase, there has been a rise in demand of digital skills and which is very good point for you to note is that amongst the graduates and working professionals, and the education sectors needs to respond accordingly. Now, since you are all from mathematics background, there is a very fantastic scopes for you in the near futures, which we all know that mathematics is the backbone of everything, all the technology fronts and all. But when we did our times, like you are the future generation. So our time, those disruptions and all were not happened when we were doing the studies and all, during graduations and all. So but right now it's the boom, it's a appropriate time for you to choose the right path, track, and increase your skills accordingly. So this change is common factor across the industries and all. So the right like the diversity of thought, attitude, approach uh, are the new possibilities are coming up. So with that, I will go to the like what I will cover up. So these are the buttons I'll press today. We'll talk more stories. We all like to hear stories. We'll talk about the disruptions. What are the digital disruptions, technological disruptions are happening around us? The industries, since I have almost worked in many diverse industrial sectors and digital transformations. Basically, I am working from past more than 6 7 years. So whatever the knowledge I gained and whatever the I will share today. We'll also talk about, of course, the data science, specifically the AI and the families. And we'll follow up, end up with the question answers and all. Fine. So the definition, basically, you need to know, what is digital transformations. So by definition, digital transformation is the organizational and operational change of an organization, like industry or ecosystems altogether, societal change, the smart integration of digital technologies, processes, and competencies across all the levels. So it's an overall change. It's if you wanted to do a digital transformation in an industry, it's an industrial change. In an organization, it's an organizational change. In a society, it's a societal change. So there are a few things which you may get confused, and before you get confused, we wanted to clearly define uh, the the meaning of that. So that's what I wrote a brief note. Digital transformation is different from digitization and digitalizations. So I know by now you are a little bit of maybe confused of digital transformation, digitizations, or digitalizations. What are these? Well, digitization is actually, in short, is the process of converting information from a physical documents to a like analog to digital, basically, and digital format. So in file systems, let's say we'll go with an example side by side, banking sector. So in previous few from few decades before, in banking industries or in insurance industries, everything was in file formats and all. So they first thing that it is the digitizations from analog to digital format. Now, once you do that, is it the end? No. There is a next step. Then what is the benefit of it? There comes digitalization. So digitalization actually is the process of using the digitized information to work more simply and efficiently, like as we went to the example of banking system. So in banking systems, once everything got digitized and into the digital format, there comes the collaborations. So and the fax things first came into picture, then emails, transactions, the document sharing, it became very easy. So that actually you'll find increased importance of digitalizations in business today. Okay, so that's the difference between digitizations and digitalizations. So digitization is the first part, and digitalizations is the second part. Now, what is digital transformation then? What is it? The change. So digital transformations came thereafter. It's actually changing the way you conduct your business. It's like, for as we'll go back to our example, the banking sector. So once they are well versed with the digitalization things, then some banks took this initiative as like, let's go for a digital transformation, let's change the way we were doing the business, let's change from our core banking to more specialized banking, and let's shrink the time frames. You might be well versed with a few loan processing things and all, which was very lengthy process few decades before. When you do the physical applications, it will go to it will fall into a workflow, and then on certain day it will be underwriting departments will go through these, whether it is approved, disapproved, few more documents required here, then it's a month-long process. They shrink this. So the what the main idea is, like, no, the how you conduct your business, to change that, to enhance your business, digital transformation things came into part. So it's about taking a step back and revisiting everything you do. So they just, with the digital transformations, they just took a step back and see, this is the way we were doing our the business processes. So where we can optimize our business processes, where we can include new business processes to replace the old business processes and enhance our ROI, the return of investments. So that's about the transformation part. So my topic today will be purely on digital transformation, the business part, but I'll also talk about technology things and what are the mathematics behind it. Moving to the next slide. As we said, we'll tell stories today. So let's start with the failure stories, because it's for me it's easy. It's good to know the failure stories than the success stories, because we can learn a lot more from the failure stories. So that's just a thought process. So here you can see the Kodak failure. So we all know the Kodak films, right? In our days when we had we did not have a digital camera, we had those analog camera, and we had this Kodak, Konica films, and we used to that was the era of it, right? So the Kodak, now where is Kodak? Nobody knows. So they are there in the market, but shrinked. At times they were the leader of the market across the globe. They have presence in many countries. So they failed in these digital disruptions times. Now the Kodak's management's inability to see digital photography as a disruptive technology. So they could not see the future of it. And it's not that they did not sense it, they sensed it. And in fact, they were the first company in this photo industry or film industry, like photo film industry, that they sensed the digital things first. And in 1975, one of the Kodak engineer who invented digital camera, and then the management could not realize the potential of it. And so they thought that, no, what will happen with the digital camera, because every world, everybody is like, no, are already talking about the uh, and we are already success, so their success, actually they're blinded. So that was one of the major things. They failed, and uh, they had time. Actually, they had almost 10 years of time since they initially pitched in with the digital mm, camera things, but they could not use their times. And when they realized that that could be a potential business for them, it was too late. And later they have taken a multi-million-dollar program to like, no, make the digital cameras, but it also failed because uh, they could not replace the film part of it. They invented a digital camera, but that digital camera required a normal traditional the film of it. So like, no, the people rejected. Why to use a digital camera if it still need a physical film? So that was a big failure story, and everybody in every industry talk and every forum, they talk about it, this Kodak's failure. So I thought to discuss this along with you today. So the next failure stories will say briefly about GE Digital, General Electric. So it's a big company. Again, they have a presence almost every part of the world. So GE also invested heavily on their digital transformation program. They even established a like, no, company called GE Digital, and thoroughly invested with cutting edge technologies and everything. But it also failed. The reason is, like, they were not aligned with their other business sectors. Like GE, we know, right? GE, their presence in healthcare, GE lights and whatnot. So their other sectors were not in line with that, the digital transformation. That's why I told beginning that transformation, digital transformation is a big topic. It's not about, like, the technology adoptions, or like, revamp your infrastructures. It's not only those. It's more than that. It's about changing people. It's about changing people's mindsets. It's changing people's skill sets. Okay? Changing the entire the business processes. It's a lot. The unit's objectives were actually G Digital were strikingly different than the company's the, the core expertise, and they were very rush or hurry in transitional effort. Again, there is a one thing I should mention, that any transformation or any change doesn't happen in a blink of the eyes. It takes time, because you are you are you are doing a transformation. You are bringing a big change. So change always takes time. It's not so they did those many mistakes, and so their multi-billion-dollar program failed, and it was a disaster for them. Well, so moving ahead, then what is the success stories? There are many success stories. So we will not go through them, but what are the main drivers of the success stories? So most enterprises that try digital transformation achieve only like, they do partial success. The full end-to-end success needs a very good strategy, um, very good leaderships, and very good vision. So the success stories and the success factors basically like no fall into these broad categories. There are many categories, so you cannot actually shrink them only to five, but majorly these are these fives. Like we should have a very high power or high influenced the leadership, then the building capabilities for the workforce for the of the future, like workforce, like the skill sets of your developers or whoever is very much involved to bring the change, empowering people to work in new ways, giving day-to-day tools and digital upgrade. There comes technology and the communications. The fifth point is very, very important. At least I have seen this, personally witnessed this in few industries. The communication frequently via traditional and digital methods, whatever methods it is, but the communication, like from for whom you are bringing this change. Probably you are an organizations and you maybe let's say a product development company or service company. Let's say again we our like no example banking. So for whom you are bringing this change, you, as I mentioned, the loan application process, I may bring this transformative change in loan application process, and what if people could not adopt it? General people, they do not know. For them it is very much technical or very high to, because we need to like a banking sector need to target to lot of different kind of audience, people, so their maturity levels could be from 0 to 10. So your transform or your product or your changed business process are there friendly of that, and whether you did sufficient communications before bringing this change. So these are some factors which highly influence to your success story. Fine. Let's move ahead and talk more about the digital disruption. Okay, so last decades, I mean to say like 2001 to 2010, we have seen some exponential growth in disruptive technologies. Uh, Basically, in last decade, we have seen how the the smartphones, how it evolved. iPhone came into picture in 2006-7 time. Tablets came. Internet connectivity. Internet was there, but internet connectivity usage was more in so we have seen a lot of digital disruptions in last decade. The computing power and storage technologies became bigger, faster and cheaper also. We still remember that when first cell phone came, I have seen in 2001 2 time. Yeah, so their incoming and outgoing rate was there, and it was very high, and we had a very big like Siemens, Nokia devices. But now it's, you see, and even not now, even many years back, it drastically changed. The storage things drastically changed, and it became possible to process and analyze huge amount of data in real time. The data processing speed, computing speed, everything increased. Last decades, the first half gave us smartphones, social media, big data, cloud. Those all comes in first half of the last decade. Google Map, I think, came on 2005, which changed like the people's life. Uh, your smartphone today, now we have smartphone for everyone. We has several million times computing power. then Apollo 11, the computer which was used in Apollo 11, the success of Apollo 11. Even our smartphones today, which we are using, these are very high computing. This has very high computing power than those era. So the point here is to convey that the devices which we are using today, the tablets or smartphones, back in time, though the computers or supercomputers had very less computing speeds. So uh, this was a huge digital disruptions in digital industry. Amazon Web Service, like 2006, it launched and it changed the world. Many startups would not have been possible if we would not have get the Amazon Web Services, or right now many Azure is there, Google is there. So it became possible for cloud computing and less pricey uh, computing power for the new upcoming the startups. It got possible for those evolution. We'll talk more on digital disruptions, and I just wanted to give you some mind-blowing facts about the big data. I will cover the data part of it in later slides. Here, just few things I just wanted to show you that how the data is increasing, on a daily basis. 300 hours of video are uploaded to YouTube every minute. And even when I am talking or to you or giving this webinar, I am also contributing the data part. Almost 5 billion videos are watched on YouTube in every single day. Google handles 3.8 million searches per minute on average across the globe. Per minute, 3.8 million searches. 1.62 billion visits Facebook daily. Facebook's process 500 plus terabytes of data each day. And one fact was there, like whatever the data available at present, 90% of those data was generated in last few years. So that comes big data into picture. So big data makes insights real time and enables artificial intelligence that is revolutioning automation. I heard in I think yesterday in someone's presentation, someone was asking about artificial intelligence and all. So I have covered this in today's topic. We'll talk more. We'll know more about artificial intelligence. Okay, so in a nutshell, what I wanted to say is digital success is not only about technology, even though the technology is a major part, but again, our core topic is digital transformation. It's totally is not only about technology. Success, if you adopt all cutting edge technologies, it doesn't guarantee that your transformations will be successful, as I already mentioned earlier. So there is a digital strategy which is very important. The digital strategy drives the digital maturity. The power of digital transformation strategy lies in its scopes and objectives. So as whatever I mentioned as an example of banking sector. So the strategy, scope, objectives, communications, leaderships, those are all uh, are the catalyst to get a successful and digital transformation. Okay, so let's talk about few industrial revolution. Right now, we are in industrial revolution, 4.0, and this is like it's not I'm not saying in India or any geography or in US. And overall in globe, we are in 4.0 in industry revolution. So what does that mean? What was 1.0, 2.0, or 3.0? In 1.0, actually, the machine came into picture long time back. It was all manual work and all. So industrial revolution 1.0, machines came into picture. The weaving machines or the production machines or grinding machines, lot of machinery things came into picture. On 2.0, mass production, assembly line, electrical energy, those all came into uh, 2.0 revolution. In third revolution, we saw automation, computers, and electronics things came into picture. So uh, now we are in 4.0. So there, cyber, physical systems, Internet of Things, networks, intelligence, machine learning, those all came into picture in 4.0, and it's still uh, uh, probably in your time when you will when I say you, I'm targeting to the students, not the professionals who are already in this field and doing a lot of research works and writing papers and contributing to the organizations or society or like no at the education body. I'm targeting to the students who are in still in graduations or post graduations. So I have seen this because I worked in multiple industrial sectors from IT, of course. So I have witnessed the digital transformations how it was. When in Japan, I have seen that they are not limited only the 4.0. They are into the societal uh, transformation, the digital transformation for society 5.0. If you Google, probably you can see what is society 5.0. So they are bringing the digital transformation to people's life, societal change, the healthcare, the many other sectors, like every other sectors basically. So they are bringing this digital transformation to societal change. So it's not about like no the digital transformations, it's only for the organizations or the research industries or the production sectors and all. You can bring the digital transformation to for everybody in an entire society. In banking industry, it was more AI chatbots and all came into picture. Now, while saying AI, sorry, so artificial intelligence is altogether a subject. It's nothing new. I think it came back in 1950s or 60s time, artificial intelligence, but it got into limelight, or uh, mm, lot of branches of AIs uh, are appearing now, or maybe not now, from last few decades. So machine learnings, machine learnings, deep learnings, those are all part of artificial intelligence subject. Even when I was doing post graduations, I had a subject in artificial intelligence. So it is there. It is there from quite some long time, but the usages of it are not much old. So the banking sector, you might have seen that chatbots things are there whenever you need not to call the help desk every time. A lot of your queries are getting resolved in chatbots and all. So these chatbots are basically, since we can see this in the screen, I can tell probably one or two lines on it. The chatbots are basically you remember we had an FAQ, frequently asked questions, in all the service websites and all, banking, insurance, or whatever. So first, what happened is that transformed into chatbots, so that you can chat and get to know your feedback. And it was not much intelligent. It was blunt. Only they changed from FAQs to digitized or digitalized the deed. And if your query match your stored answers, it will answer you back. But it was not intelligence. Then they brought AI into to enhance the chatbots. Now chatbots are intelligence. It's a small robot you can answer. You can think like that. So it's like based on your search questions, it learns. If it knows, that it will answer. If it doesn't know, then it will take your questions, and it will enhance the its processing, and next time again it will give you this answer, the right answer. So it's a continuous learning that comes in intelligence. So uh, that was one of the thing. And next is the insurance sector. Again, the financial sector, uh, digital, the patient care systems, like in US we have we cannot think life if we do not have insurance. So and once you're get insurance, and you go for any ailment to hospital or any medical facility, so your all processings and everything goes cashless. Even in India, these are there. So that entire supply chain systems got revamped. Must say that they transformed the business processes. And the technologies such as beacons, augmented reality, AI, those are all came into retail sectors. If you there are this itself is a big topic. If augmented reality or beacons, beacons is you can say like a transmitting kind of technology. It's like when you search in Google, let's say I want to buy a nice pair of shoes, where I'll get it. So it might give you certain results, and based on your locations, it might tell that no, these are the stores nearby. You can go, and suppose you selected some ABC store, and you went there to the store to search for the same nice pair of shoe. And so the moment you enter to the store, and if it has this beacon device in its store, uh, it may read like from the data from your smartphone, that similar search was done from this. When we do search using our mobile device, every mobile device is a unique ID. All mobile devices have a unique ID. So if those IDs and all are matched, then it gets like feed that yes, when I advertised in Google search, I invested. From the store perspective, I'm saying they might have invested $2,000 in Google search. And if they see that their sales increased like a lot, and all are because of their search things, because when people search in Google, they come to the store, they can buy the product, and my sales increased. So that way they can uh, decide whether to keep their advertise on, increase the advertising in Google more, or they should just get rid of this if they do not turn up any customers, or if the sales do not grow. So these are all the business ideas which used the technologies to enhance their ROI. Augmented reality, virtual reality, these two are different things. Virtual reality you might have seen or experienced by wearing some glasses or devices on your eyes, and you are completely into that world. Let's say you are watching Jurassic Park movie and you wear virtual reality glass, you will be in that era, and it's just an entertainment purpose. Augmented reality is different. Augmented reality is much used by the retail sectors. Even I worked in retail sectors in Sweden, and we also implemented that in one of our big program. Uh, it's like I want to buy a corner chair, a corner table. Okay, so my house has one open space, this corner in this size. Whether this, and I'm browsing in Amazon or any other websites which has this augmented reality feature, and if I see that this product, I choose some product, some nice corner table, and whether it will fit to my, and how it will look before deciding that I'll buy. I can see, I can take my mobile phone and I can put this corner table into my house corner. I can see how it looks like, and if any color matches to my wall background or other furnitures around, I can say, okay, this is the. So these enhance the like experiences, sell experiences, selling experiences of the customer, the purchase experiences. So they can learn. Okay, so by introducing augmented reality, my sales has been increased of so and so percentage, and it's really useful. I have experienced this. I bought a couple of things in past using that feature. So in retail sectors, in a nutshell, I wanted to say that digital for retail is more, and it's still increasing. You can just take Amazon as a big example. So these few of the industrial talks we made. In manufacturing sectors, again, this digital is in a rise with an increase of IoT devices and all. IoT I will cover probably if time permits separately. So what we know that with by using the technologies in one point or in the another view is that that's data. It's all about data. Whether it is any industry, banking, financial, or whatever industry, it's everything happening on data. Back in time, as I mentioned, that artificial intelligence was not in boom because there was not much data. For machine learning, you need a huge amount of data to make your machines learn from its own. So these are all happening now because we are having lots and lots of data get generated every day. So that's what I was talking earlier. Gartner predicts that by 2022, 90% of corporate strategies will explicitly mention information as a critical enterprise assets and analytics as an essential competency. So those are the areas. It's actually going to bring more scopes or revolution on the data analytics and data science. I personally will suggest that if anybody has interest on data science and all, go for it. It is having a bright future and a lot of things you can do. Whether you are a student or a research scholars, so that sector is has a high potential. Now, as I said, we'll go to the big data and the data science. Big data. Big data is just a word. It's all came from the data revolution. So big data, business intelligence, business analytics, machine learning, and artificial intelligence. We know these buzzwords belong to the field of data science, but what do they mean basically? So that may really surprise you when I talk about the data science. That data science basically will answer 5 questions, just 5 questions. They can answer you, and I will go through this in short while. Okay, so each of these questions are answered by separate family of machine learning methods or algorithms. When I said algorithm, you might be well versed with this, and you might have experienced a lot of algorithms in your many other way. So what I understand algorithm is as a recipe. For me, algorithm is a recipe, and my data is an ingredient, and my computer is a blender. So I put, I know my recipe. I take data, put it into my blender computer, which has very high processing power. Finally, I get my juice or smoothie ready. So that's about like the concept how algorithms turns into your the outputs. The 5 questions which I told the data science can answer is like is this A or B? Like this family of algorithm is called classification. When there are 2 choices, it's called two-class classifications. So the classification algorithm, whether it may have more options like A, B, or C, or D, and it's called multi-class classifications, and it is useful when you have several thousands of answers and you have to choose. An example when this algorithm might be, or where it is useful or it is in use. Suppose you are driving on a long drive, and your tire pressures and sensing that how much mile it can go more, whether it will cross next 1,000 miles, yes or no, that kind of decisions. For retail sectors, like whether they should go for 500 rupees discount or 25% discounts, which will fit good for their sellings. So those kind of decisions and makings and all, this can be they are using this classification algorithm. The next question is this weird? That's called this question is answered in data science by anomaly detection algorithm. The example is a credit card. Okay, so let's say the usage. Now I have a ICICI Bank credit card, and I'm not aware, but banking is constantly following me. My purchase patterns, the usage purchase patterns, where I mostly use, and if there are any anomaly detected. I have personally experienced this when I used my ICICI Bank credit card in a transit in Hong Kong, and later I found a big mail from ICICI whether it was me because my usage was found detected in another country. So those anomalies getting detected by analyzing the data, and it's not done by a person or something. It's all fitted. The algorithms are there. It's in the system, and whenever there will be some this kind of events occur, it will generate. The event will shoot out. So in data science, those getting into, and the third question is how much or how many. For this question, you don't have example that that you already know the outcome is, how it is organized, if how much or how many. There are a lot of ways to tease the structure of the data, and one is called clustering. Uh, so it separates the data in natural clumps for easier interpretation. And with clustering, there is no one right value or the right answer. Okay, so the common examples of clustering questions are like no. It's actually done by Netflix or Amazon Prime, like based on your usage of or watch history of movies. It suggests you whether you will like what type of movies and all, or so that getting used, and they use this the regression algorithms and clustering. The fifth question is okay. I'm sorry. I think I messed up. Okay, so the fourth questions was clustering, and the fifth question was the reinforcement learning algorithm. Uh, Reinforcement learning algorithm is typically getting used nowadays uh, in auto sector, wherein driverless cars are there by Tesla, right? So these are basically reinforcement learning are inspired by the brains of rats and humans, which respond to punishment and learning. So these algorithms learns from outcomes, whether you did a wrong or you did a right. Suppose there is a driverless car on one signal, whether at a yellow light they should slow down, and in red light they should stop. This is the the driverless car, right? So it's all automated. So if it does a mistake, it learns from that, and so this reinforcement learning algorithms are basically used on that. So that is few examples of data science, what type of questions they are answering. That it's a multidisciplinary field, and so in data science there are many sections, or these few things I highlighted here. Here are the mathematics, statistics, Python, machine learning, deep learning. Those are all branches followed in data science. So mathematics is the core, because I will show probably in next few slides more how the mathematics, or what portion of mathematics are used in, because mathematics is, or like what mathematics, whether it is a linear algebra or statistics, probability, what. So I will give you a very good slide I have. You will get good knowledge. So it's actually learning the tools is the first step to doing the data science. You must first see the big picture. Then only you can study the details part of it, right? So calculus and linear algebra in mathematics are essential for programming in data science. Statistics, the advanced statistics, those are big part in data science. Data science is all about this, the predictive modeling, the regressions, clustering, factor analysis. Those are all disciplines of statistics being used in and advanced statistics topics being used in data science. Python is a programming language which is very high capacity and rigorously used in data science and by many industries. Artificial intelligence um, uh, is like what I said, like machine learning and deep learning. The part of artificial intelligence are used in that data science. Okay, so now each of these topics that I mentioned above builds on the previous ones. So everything first, the understanding of the data science field, the types of analysis carried out, because in data science, what type of analysis you are doing, which type of data, whether it is financial data or the market data or the manufacturing data, production data. So first, to understand the type of the data. So and you risk if you get lost, if you in the way, and if you do not acquire few of the skills. So if you, for example, one would struggle in the application of machine learning techniques before understanding the underlying mathematics, right? So machine learning techniques are mainly dependent on few mathematics branches of mathematics. So if you do not know, or you do not have much experience on those, it will be difficult for you uh, to learn the machine learning techniques. So like no, or it can be overwhelming to study regression analysis in Python before you know what the regression is. As I mentioned, like Python is widely used uh, language in data science. But when you even I used to Python in few of my earlier or the programs or projects. So those it's having, it needs the full knowledge on whether you have, though you there are a lot of built-in libraries and all, you are really developing something like big development, you need to understand more. So to learn Python, in a nutshell, to learn Python, you need to have a solid mathematics knowledge. So that's how the important, like as a student, you are the mathematics student. So it's to contribute or to follow your career path into those lines. It's the foundational part, mathematics. So there on and but there are again a lot of ways, whether you want to go to the data science way, or typically the computational part of it, or whatever. So everything you will not get with like no. It's if somebody say, okay, you are from mathematics background, you can do all those things. No, not all those things. And typically, specifically few things, or specifically many things, but should be in a very specific. Being said that, machine learning, I think we should cover a little fast. So a good example of machine learning implementation is Facebook. Uh, Facebook's machine learning algorithms gather the behavioral informations. You might have seen that if you do Google search or a lot of things, you want to buy a laptop and searching a lot of laptop brands, and then you are still looking for it, and next you just open Facebook and seeing your feed, you might see that those some advertisements are coming and showing you that these laptops are good, these are high powered, those HP laptops are nice, ThinkPads are very good, in your Facebook feed. Those are all those are concepts of machine learning. Based on your one's past behavior, the algorithm predicts interest and recommends articles and notification newsfeed. Similar things happens in Amazon, Netflix, Amazon Prime, everywhere. So they are heavily use these machine learning things. Uh, Moving next is the mathematics behind the machine learning. The various maths concepts required for machine learning, including linear algebra, precisely, the calculus, probabilities, statistics, more. Statistics, no, I think statistics are more used in data science. Yes. So machine learning concepts are tied to linear algebra. For example, this principal component analysis requires eigenvalues, regression requires matrix multiplications and all. Most ML applications deal with high dimensional data of many dimensions. The type of data is best represented by matrices. Calculus is also important for several key ML applications. So, as I already covered those portions. Now here, I wanted to tell you a little bit more, like uh, data science, machine learning, what are the differences and all, right? And what are the how the mathematics is involved in these two, and how much extent the mathematics is involved. So probably this radar plot will give you a little bit of idea. Over here we are showing these two pictures of data science and machine learning, and from a scale of 0 to 5, what portions of mathematics are used in those two categories. I have many more such examples, but due to time constraint, I cannot cover here. But again, you can always reach me established platforms. I will share with the organizing committee. If you have any way you wanted to know more or any help required, anytime you can. So here to cover it, let me just briefly explain. The probability in data science, statistics probabilities are majorly used. I already told you. The calculus is not much, but again, it's yes, from a scale of 0 to 5, it comes to 2, and linear algebra 2. But you see the linear algebra and calculus usage in machine learning, it's an extensively used in machine learning. So that way you can like no as a your as a mathematics background, you might have some forte, right? Like you might the linear algebra might be your strongest area interest you wanted to do, or as a research scholar you wanted to do some research on a digital part by using linear algebra. So what exactly you can target, so that may help you a little bit. Deep learning is a big subject in itself. I'll short or briefly cover deep learning, machine learning, artificial intelligence. And what are the connections? Like as I said, artificial intelligence is a science. It's a big it's a big book. Okay. Now in that book, or in mathematics language, I'll say it's a superset, right? Machine language is a subset of artificial intelligence, and deep learning is the subset of machine learning. So deep learning is more of a neuroscience, neural networks, your brains, the versions. If you are developing a component model, small robots, right? It should have the intelligence. You are putting some intelligence powers in it. So few examples are like the virtual assistants. These are all in already used, or these are already in use in today's world. Virtual assistants, translations, the Google translations or any language translations, driverless cars or trucks, drones, chatbots, image colorization, facial image recognitions. These are all based on the deep learning. Um, even this iPhone, Siri, Amazon Alexa, those are all on the machine, sorry, the deep learning fields. So when I said linear algebra, right, it is, I just wanted to give you a brief example of how the linear algebra is, by saying that I wanted to conclude for today. So I just why the linear algebra is actually useful, or where. I'll just give you a brief example here with an animation. Uh, this image recognition, you might, everybody of us in this today's world, we know that image recognition, what is it? When we open my phone and it's recognize my face, that's a image recognition technology. Okay, so in past few years, the deep learning and the deep neural network in particular conquered image recognition. And on forefront, there is a CNN, or the convolutional neural network, in short, which is being used in image recognition. So now, what is the idea? What is the idea behind it? Now, basically, you can take a photo and then you pass it to an algorithm, and classify it. So that's pretty good. But can you just fit a photo to computer? No, right? So you need to you need to convert it into the digital format, which computer and binary digits, ones and zeros. The famous examples here are these data sets where the task is to classify handwritten digits. Cipher 10, where the task is to classify animals and vehicles. Cipher 100, where you have hundreds of different classes of images. But to pass it to a computer or an algorithm which is in the computer, we cannot, we must find a way, what way we should adopt to analyze this and make the our intelligent software, or this one, to make a decision what is that. Well, so here, let's see, we must find a way to design the photo to numbers in order to communicate the image to the computer. And there only the linear algebra comes into picture. So each photo has dimensions, right? Every photo, we have megapixels, pixels. So let's say this is a 400 by 400 pixel photo, and basically, if you see, each photo is each part of the photo. If you zoom in to the highest possible extent, you will see each part is a colored square. It's a colored square. When you zoom out, this is the version of the zoom in, you will see a colored. This is the only extent I can go, but if you can go to the highest extent possible, you can see each portion is a colored square. Now, when we do zoom out, our brain perceive that it's an image, and then our brain classify these as a dog, right? So that's our brain understands. So let's dig further into it and take an example of a gray photo. Now, the gray scale contains the 256 shades altogether. whereas 0 is the totally white and 255 is the totally black. So this photo, whatever you are seeing now, is a 256. It consists of 256 shades of gray, different shades of gray. The 400 by 400 pixels are spread across into 256 shades of gray. Okay, we can actually express this photo as a matrix. Now we are connecting, right? The linear algebra comes into picture. So this 400 by 400 matrix we can consider it as, and each element of this matrix is from 0 to 255, and it shows the intensity of the gray. Okay, so and basically, and that's how the computer understands. Now computer understands between, and computer can convert this into its binary digits format, because we all know, right, that each portion is a colored gray, and it is from 0 to 255, and it will have a respective hexadecimal codes, and we do have a 400 by 400 matrix. So now the computer understands that this is a picture, right? Now what about the colored photos? So the colored photos, now so far in gray photo we have seen, like, no, we have two dimensions of it, right? 400 by 400 and the 256 shades of gray. Now with colored photo, like, no, we have we know that now in color photo one more parameter got added, and that's one more concepts come into pictures, the RGB scales, red, green, and blue. So this is a universal scale. Any picture you see, it consists of RGB. We'll go a little bit, we'll know a little bit more on it. So in order to represent a colored photo, like, no, to digital format, or like, no, in order to represent the colored photo in linear algebraic forms, let's take an example from before, the dimensions of the colors when we had a gray, right? As I said, like, no, the RGB will have to R the red color, each color, right? When we expressed about gray, so we found 256. Here's red 256, green 256, and like blue 256. And let's say if we see about the purple, so the purple is a combination of 138, 106. This color of purple, probably little light or little dark, will have different numbers altogether. So let's represent this color photo in a linear algebraic form and see how it comes up. So there we'll just start again from gray, and then we are putting actually, like, no, we are considering the three colored, like, no, red, green, and blue. So we are actually introducing another parameter, which is like, no, 400 by 400 matrix, each for red, green, and blue. And what is that? You know better than me. It's a tensor, your favorite mathematics jargon. So it's a like, no, it contains basically 400 by 400 matrix, each one for red, green, and blue. It's a tensor, and how this is how the deep neural network works with photo. Now we saw that, no, from one photo how we are segregating this into a matrix format of 400 by 400, and then how the tensor things comes to picture. So this is just a very basic level, and with these the foundational things, they uh, introduce this linear algebraic mathematics, and transform this into major developments and all. So with this, I I basically wanted to conclude, but again, I wanted to again tell that the digital technology forces. If you can see here, you might uh, from the Googles or internet search or a lot of chit chats here and there, so you may see that there are lots of technologies, and all are jumbled together, like blockchains, drones, driverless vehicles, algorithms, big data. How these are like, is it all disrupted now? Back in 5 years, no. This is not the case. So that's why I wanted to show you here is like, no. You can see here maturing, emerging, and more than 10 years. This quantum computing. Someone was telling about quantum computing, I think, in some lecture. So those are all pretty established, like human augmentation, brain computer interfaces. Emergings are here blue. You can see this social robotics, commercial drones, sensors, IoTs. IoT is basically all sort of sensors. So that itself is a big topic, and which are used more in our uh, um, across the world, like smart city, smart hospital, smart office, smart mall, wherein you just go there and buy things, come up, like you need not to checkouts and all, everything happens. So those are all sensors based. Basically, there are many types of sensors getting used in IoT now, wherein my I can control my temperatures remotely, and I can configure my home appliances remotely. Those are all already in the market and already used. So IoT is one more field evolving. So the conclusion to here is, again, we talked more on technology things, and it's not very uncommon. Whenever you will talk about digitalizations or digital transformation, you will end up discussing technologies more. Whereas you should remember that very carefully, that transformation is not only about technology. Successful transformation is all about the strategy, your leaderships, and your communication, and how you connect, or like what transformations you want to bring, and for whom the transformations you are bringing, whether you are connected with them. So those are the major success factors of digital transformations. Now, with this, I will conclude here, and I will switch to Devashish to open the Q&A line.
Thank you very much, Joydeep sir, for this wonderful presentation. Your slides were also very nice. It provided a visual representation of what you were trying to say. And one thing I should say, that particularly the younger generation participants will find it quite interesting, in the sense that you had explained about those RGB color combinations and how matrices come into the picture. So when we click a photo in smartphone, and immediately there are options like change the background, change the color, and modify it, editing it. So there is a lot of technology involved behind. We just click it, or we just swipe it with our fingers, but there is a lot of technology involved behind. There is a lot of programming involved. There is a lot of mathematics involved behind. So all of us must appreciate the advancement in technology that is going on. So nowadays it's a very common term to, whenever we go to buy mobiles and all, we always care about megapixels and all. So that's a very common term, but lots of technology is involved within that. So I'd like to begin the question answer session. So let us begin from we have a lot of questions from participants as well. So let us begin from our speakers first. Dr. Anirban Roy, he is also there, and Dr. Swapan Malik, he is also there. So let us start with their feedback. Yeah. So it's actually very nice. Usually, means I have attended a number of webinars or seminars also. Usually, I find only the speaker of the present participating in the discussion and participants participating. The other speakers usually, I'm not saying in all webinars. Usually, it happens that other speakers they do not participate in the other talks, the talks by the other speakers. So here we are experiencing something different. Every day we have a number of speakers who after even after their session are participating in the webinar. So that's a very good thing, very positive thing. So let us have feedback. So I'll go first to Shopan sir. Yeah, he's also from America. Yeah.
Yeah. Hi, Joydeep. Thank you very much. And the talk is very informative. For me, it's really big things. I today I learned a lot of things in fact, and since I am working on in our weather forecast, we are also working on machine learning, deep learning. Yesterday, I just saw one or two slides. What is the future uh, of mathematics in deep learning? So it's really very interesting. And yeah, the presentation is really good for all the students who, especially not only in mathematics but for all subject, all science.
Right.
So thank you very much for your presentation. I have one question, not question, just curious to know the thing that you have mentioned the Amazon, this series or this
Web
data
service.
storage.
Yeah.
So I just want to know how much secure is that? Means like we have nowadays Google this. We are using Google TensorFlow and other things for platform wise. So, would you like to
Yeah.
comment on that Amazon this platform
Right.
for artificial intelligence?
Right. So yeah, Google's like no, they have a state of the art deep learning framework which is called TensorFlow. I know in your field when like no thing and anything sort of the deep research you are using a lot of or you need a lot of aid or you are using a lot of aid of ML and deep learning things because these are specifically for the code R&D work. Coming to Amazon Web Service, AWS, you know, this is the first, I will say, they are very established in the market. I think they were the first who had the Amazon Web Services and the basically the cloud hostings and all. And as far as the security goes, it's very highly secured. You on premise, if you maintain your own private cloud, right? I've seen some organizations are managed because of their thinking about like no data, sensible data, the business data, or probably let's say some what is that, NASA or some organizations who has very crucial informations
Yeah.
in terms of security,
Yes.
atomic plants, those. So those they ask usually that no how secure my informations are, because I'm trusting completely on a
Yes.
third party and whether it should. So yes, it has two aspects. One is in terms of real security, it's totally secured in Amazon Web Service. Now there are two things comes into picture, as I said. One is security, one is trust. Okay.
Yeah.
So they both go hand in hand in those organizations who, like I said, no NASA. Probably NASA is planning for something to launch or satellites, and that Russian some are also doing some research on similar field. Who wants to go first to the moon? Okay, that kind of race. Okay, now if they both use AWS, they may think that no, we are using both we both are using AWS, and can we trust them? What if because Amazon will be the master of keeping those data into their platforms, so that comes a trust. And in terms of security concerns, it's highly secured and lot of data, so you can like where you are hosting, even they cannot take your data out, because those will be very much highly encrypted and all. So though there are in that itself is a separate science field.
Yeah, that's true.
Yeah, so that security, but again trust is very different. You cannot control that.
Yeah. Okay. Thank you very much. Thank you. Thanks for the information.
Thank you. I'll now go to Anirban sir.
Yep.
Yeah.
Hi.
Yeah, you are on screen.
First of all, thank you very much, Joydeep, for an excellent and wonderful presentation. Because I'm a core mathematician, not in the industry, but still it was such an informative. And I also, while going through this presentation, and now as Dr. Debashish mentioned that Malik also here, you are here, I myself here. I think right, it is 1 o'clock night in your place, Joydeep's place.
Yes.
And probably, but I should thank Dr. Debashish and the Department of Mathematics for thinking like that, because in today's era, if I say I love mathematics, I do mathematics in my board pen paper, I think I'm backdated. There is no future for me. So industry and corporate and mathematics are now directly interlinked. You can't separate it away. So thank you very much that you have thought so nicely to bring a person from industry, and so nicely you carefully choose, and he's from industry but with a mathematical background. And particularly the way he was explaining a couple of slides, that graph or the percentage you are showing, how much it is used for, how much statistics, how much regression, probability. And somewhere he has so nicely categorized that what is it? I have noted down. I was so excited to find that it starts from mathematics, then algebra, then probability. Finally, it reaches to deep learning. Hats off to you. I mean, this is so nicely presented, and I think I mentioned it yesterday also. I can't stop from sharing the same thing today. I can see Dr. Malik from atmospheric science, myself from say topology or geometry. Joydeep Das, he is from full-time in industry. And in fact, when Dr. Malik was explaining yesterday, some student or somebody asked a question about artificial intelligence.
Yeah.
And that is answered by Joydeep to some extent, that uses of artificial intelligence are what. And directly or indirectly, probably we all are using it, artificial intelligence. In fact, this is such an interesting coincidence. I set up my alarm today morning so that I don't miss this lecture. But I got a message in my mobile that actually in our Bangalore, South India, today is a holiday. So there's a message is that you want to continue with the alarm. So,
that's an intelligence.
Yeah. And thank you very much once again to our Biplav sir and our department. We all belong to the same place after all. We all are from Silchar, and we learned actually whatever we are exploring today. We learned it from this ground. So very nicely, Devashish has organized the thought that vocal for local. So,
I should thank Anirbandha also for introducing me to Joydeep sir and Chopan sir.
Right. One thing I also wanted to tell, I have also seen a few of the parts of in one place, I think, you mentioned, probably I forgot. I was seeing a lot of your video and Shapan's video. So in one place you mentioned, back in 16th century, somebody discovered some
Yeah, it's Fermat's theorem. Fermat's theorem. Coding.
Yeah.
stage is now. And I have seen this, I've noticed that. And do you really know like why it is happening? Maybe if 16th century, 17th, 18th century is all gone, right? Everybody was sleeping that time. No, it's not. These that's why I'm telling those students who are attending today, they are very like no, they have a very bright scope in doing. We did not have that when we were studying linear algebra in our time. We were very limited knowledge of its usage as such.
Yeah.
That is why many of us had no interest. We were studying just for passing the exam.
Yes,
Right?
that's true.
Now, but that's not the case for today's students. Today's students, they know with these kind of like webinars or a lot of information on Google's or YouTube's and everywhere, they know what they're studying linear algebra and where it's being used and what are the scopes. So, and that's all happened because of last few years, the data, the tremendous increase of data, also contributing data increase now by in this webinar. Okay, so tremendous increase of data, the lots of scopes got added, like artificial intelligence, 1950s or 60s, someone like I forgot the name, but the person discovered. After that, nothing, because where it's its usage, there are might be lot of mathematical topics, formulas, research papers already there, which Dr. Roy probably is working on something, Sopan is working on something, and few other scholars are working on something that might be useful. You do not know, maybe down the line another 50-60 years will not be here, but those usefulness will be coming. So there is not discrete things, it's all connected together, everything is connected. If not today, tomorrow something will come, some evolution. Today data evolution, everywhere data. So data is the main, the final point is data. Because of this data, all things are possible. If no data, so many days like 16th, 17th, 18th centuries or 50s, 60s times, there are limited data. Where to use, where to you can like play around with your technologies and all. So that's a big point. And our future students are very lucky, and they have tremendous potential scope they have in like to work or research or whatever they wanted to pursue.
Thank
Yes,
you.
sir.
Thank you very much.
Thank you very much, sir.
Joydeep. Thank you.
Yeah, so we shall move on to the questions from the participants. So I am putting Anirban sir and Shopan sir on backstage. Thank you. So we have several questions. So the questions will pop up on the screen as I allow from here. You can see.
Actually, I am not seeing anything. I am seeing
Oh,
my
gotcha.
presentation.
Oh, okay. You can stop. Click the stop sharing option in your this screen sharing. Yeah, you can stop share. Yeah. Now I think you can see this.
Oh yes, I can see myself now.
Yeah, that's good. Okay, so this is one question. What is this? Can you see the question? It's from Trilokya Mohan Goswami. Is there any digital device in the communication system of bat? Is a vampire? So
Communication. I did
I
not
can
understand much.
relate why vampire is mentioned here. Okay, maybe we can skip this.
Yeah,
Okay, let me see. Okay, so this is another question about from Aditya Das. Can you please say something about data cloud
yeah.
and about its
So
usage?
right. So cloud is another segment, another science. Like I already told, artificial intelligence is another sector. Cyber security is one other sector which Dr. Sapani was asking about, like on security things. The cloud is altogether a separate. You can should have multiple webinars on cloud computing. Yes, as I already mentioned, like AWS, Amazon Web Services, We have from Microsoft also Azure cloud services, from Google's also. So, and you have a private cloud, public cloud, hybrid clouds. Okay, so it's all virtualizations, your machine virtualizations, infrastructure virtualizations. There are a lot of infrastructure as a service. Everything is service as a service. Like no platform as a service, infrastructure as a service, software as a service. You for your just quick reference, you can think Office 365, which you are using probably as a Microsoft Office nowadays, is actually a software as a service, is SaaS component of Amazon. Do not give like no the CD or DVD or something to you, and you are just using their SaaS software as a service product directly. So when you said data cloud, I assume you mean to say where I can store the data. The example is AWS. You can search AWS or more on Google, and like no the data or anything, any data infrastructure, software, platform, everything you can host into Amazon. You just for these, suppose you are entrepreneur and you wanted to open up a new web portal for you, e-commerce portal. You just need a laptop, normal laptop, and a credit card. That's all. You don't need anything. You just use AWS or Azure. You can host your e-commerce platform, start business. You just need to have the business process in mind, business idea in mind. That is all. That's how this Airbnb and Uber, our Ola cab, those are like no are implemented their business in over the night. So these are the good examples actually.
Okay, thank you. This is another one. What is this? What is the physical significance of data science, and how can we use in real life of data science? I
Right,
mean,
right.
it
So
doesn't
already,
need to answer.
yeah,
I'll put it forward to you.
right.
The world is full of data.
Already explained this data science, how it is like no useful in our day-to-day life. Probably you can refer my presentations. Right. No, shall I explain again, or it's already I explained the like no that data science part.
I think you can skip. The world is full of. You have already explained about data science. We can go to the next question. After completing master degree in data science and big data science, how a person will be recognized as a data scientist, and how long it will take?
Right. So that is a good academic or careeristic question. So if you already did masters in big data and data science, so that means you are already well versed with the science behind it, or the topic, or the various aspects of the subject. Now, just you do not have the seal of data scientists. So as a data scientist, again, they have basically two parts. Whether you wanted to become a business intelligent analyst, data analyst, or you should work in predictive analysis. So those two both are part of the data science. One is dealing with the past data, one is dealing with the future data. When you are dealing with the past data, probably you can see in my presentation, I have indicated that statistics is a portion where data science getting used. So when you are using a data analyst, let's say in Bombay Stock Exchange, you got a job and as a data analyst. So your job is to analyze the past trends, how the stock markets went and all. probably your peer member who is also data scientist, who can who is way one step different than you. He's studying the previous data and predicting the tomorrow what will be TCS stock price, or tomorrow what will be the Infosys stock price. So there are various aspects. So data scientists, you are very much eligible for the data scientist. Only the experiences, right? Uh,
Okay. So we have another question here. Padmeshwar Senapati. He's saying, can we compare digital transformation to Laplace or integral transform? Probably he means.
Transformations, right? No. Those two are different things. Well, Laplace, I know. I do not know integral transformations. I think you misinterpreted that. Digital
Yeah.
transformation is the big topic. Now, in digital transformation, if you are all like very specific, if somebody say like no, in artificial intelligence, can I do this? Or in okay, in your word, I can say like no, in mathematics, I am a student of mathematics. Now, can I do this? Can I do Fourier transformation series? Something like we do not know, because mathematics is a vast, right? Which area specifically you are telling? Digital transformation is not like Fourier transformations or Laplace transformation. These are algorithm basic. Like these are the components which might be. I'm not telling it cannot be used in digital transformation, but digital transformation is a journey, right? So it is a train, big train. It's journey from one station to another station. It's going in its train. Some engine, some parts are also a integral part of its train running things. I'm giving an example. So if that part doesn't work, train may not move. So it's an integral part of it, but it's not the overall train as a journey. So Laplace and transformation and whatever that other transformation you use, we need to see the bigger picture of it. Then only we can decide whether it's a part of digital transformation things or not. Sorry, I cannot hear Devashish, your voice. Yeah.
I muted myself.
Okay.
Okay. I think this question is similar to the earlier one. After completing online course in data science, okay. Can a person
Yes,
recognize
yes.
himself as?
Online also, I can take that question. Online also is good, online, but you need to have a hands-on. It doesn't matter whether you take the course online or not. It's all depend on your understanding, your like how much knowledge you received, and also you need to work. Next is the hands-on experience with those things. And if you took the data science course, I assume that you already also did Python courses or something if you wanted to, but it's not mandatory that as a data scientist you should know Python. But those are all hands-on. You need to have some hands-on, and of course you need data science,
Yeah.
irrespective of your online or on-premise course.
Okay. Okay. So there is a question from Arundhati Banerjee. Is there any part-time course for a government employee in machine learning or artificial intelligence?
Yeah,
Maybe she's asking about yes, those correspondence or online course maybe.
lots and lots. You can go to a lot of established education platforms like Simplilearn, Udemy, LinkedIn Learning, and
Hmm.
plenty of others. They have very solid, even artificial intelligence, the machine learning, deep learnings, and all. The boom is so much, and the usage or the scope is so much that lots of educational platforms are providing this course. You will have video course, hands-on course, lots and lots. You will get
Hmm.
plenty.
Okay, so there is another question related to this. Would using artificial intelligence in many industries as well as jobs in India threaten the poorer background in village in living, thus making India increase in BPL?
No. Who said?
No,
That
that's
is
a
one perspective.
misconception.
The thing
Yeah.
is, yeah, I
People usually
directly
think that artificial intelligence is replacing human beings. That doesn't happen.
no,
I'd
right,
like to know your opinion.
right. It's not
Mhm.
replacing. Yeah, one thing I I got your question. This is a very it's a very common questions people.
Yeah,
It is true that it's a threat for mass scale job, right? And when I said industry 4.0 revolution, right, now, and when industry 1.0 revolution was there, that times also this threat was there, right? Like previously, you might think that or you may think in that way that a weaver who was making the cloths used to do its own by its own manually. Then machine came, right? It replaced everything and mass production started. That time also a lot of job cuts happened, right? But those people transformed themselves to a learner and they started working in the industry.
yeah,
So now what we see Indian village, probably by Indian village we think that no uneducated and lot of poor things in mind, but it's not the case. This is also getting that's why I'm saying with all industry revolution, right, social revolution is also must. That's a call for the government. That's how the Japan is like no the more advanced because they are going hand in hand. They had also more poor, uneducated, and everything, but societal change brought them together. So that digital transformations, along with that industry 4.0, I do not know in India where is the societal transformation, whether it is started or not started, but actually it started. May not be they termed it as some 1.0, 2.0, or maybe I do not know, but yes, societal change is must to bring that in one direction. It's like no it's like your if you do exercise in only doing dumbbells, okay, you might have hands muscle power, but otherwise you might have a big belly fat. So in order to transform yourself fully into fit, you should do all sort of things. So digital trans, if you see in one's perspective, yes, it's a threat. Overall, it's not a threat. It will
yeah.
transform everything.
Okay, so we move on to another question by Roosevelt. Sir, your topic is interesting. Will you give any specific example where the Fourier transform is used in data science? I have only a little idea that Fourier transform is used in image processing.
So I got answer from your question. So Fourier transformations, I did not I cannot give you right answer now. Maybe I have to do little check here there, or maybe in my organizations or Google's or something. But if you say the Fourier transformation you already used in image processing, that's the application.
Yeah, yeah. Fourier transformation is widely used in image processing. Those even in medical science, there's CT scan and all.
Mhm.
They use a lot of Fourier transform. I'm not sure, I mean, how exactly it's done, but it finds application there. Even in those communication, yeah, communication noise disturbance and all.
Oh yeah,
Those,
yeah, yeah.
yeah,
Then
engineering
it is
are
used
studying.
in your mobile also. Then if you're
Yeah,
every second, then it's already included in the disruptive technology
yeah.
transformation.
Yes, yes. So let us. Okay, so there is this question from Ramachandra. It's a tough question, probably. Is it applicable to eradicate corruption from our system?
Of course, of course.
Yeah, of
I'll
course.
just give you a small example from my example. When I said I give you an example of a loan processing system in bank, right? I have seen when I was like no student and all. I used to hear that for to process a fishery loan, like no in villages, people used to give lot of bribes to the loan officer, right? Because that loan officer is the sole power to decide whether he should give loan or not give loan. So with these digitalizations and digitizations and digitalizations, corruptions will simply go away, because now with my example only, loan processing system is it starts from your palm top, from mobile. Within 2 days you will get to know, because no human interventions will come into effect. And that underwriting is a process wherein it's much used in banking and financial sectors. Underwriters, basically in previous days, underwriters used to see your case and check whether your case is sufficient. Now though that process also got digitized and digitalized, right? So if everything is digitalized, the decision is making by machine, not human. And when machine takes decisions, corruptions will not be there. Yes, you are true.
Yes, in fact, that's quite true, and more and more digitization. That's why even the government is stressing on digitization.
I'll give
And
you one more example. In Malaysia, I was associated with a digital transformation program. It's a big. They were doing the transformations of smart meters to entire peninsular Malaysia. And when smart meters come to your home, we do also have a meter, right, which are digital meter, not a smart meter. When you use a smart meters, and the entire transformations comes into an effect. Now in that way you will not, if anybody is misusing the power, they'll easily get to know. And our program faced a lot of hiccups from the political leaders, because they had a vote bank and the mass sectors where they are using unethical way the power usages and all. So they had a negative, they were our negative stakeholders. They tried to resist the implementations. Again, everything comes into corruption. So this is one more example, like no, with digital transformations, those corruptions and all will get reduced. Again, Debashish, you are talking on mute.
I'm very sorry.
Yeah.
I'm not using the earphone, so it's having an echo problem. That's
Oh
why I
yeah,
keep
yeah,
it mute. Okay, so we have Birabhrata sir from Bangaigaon Polytechnic. He's having a question, or yeah, let me just read. Really nice. I was feeling that the speaker is telling stories, explaining, sitting in front of me is in real
yeah.
field.
Right,
So that's
right.
a good compliment from Birabhrata sir.
Thank
Thank you,
you.
sir. Okay, then. Okay, we have another question here from Vijeta Pal. Yeah, there is a technology called remote sensing. Is machine learning, artificial intelligence being used there as well?
Yes.
Can you please talk something about the career prospect of machine learning and artificial
Right,
intelligence?
right. Remote sensing, if it is a sensor, it has a lot of usage. It's the IoT. Because in IoT they are using a lot of sensors and all, and of course IoT is also somewhat integrated, because these are like no collaborative way they work. Sometimes the machine learning, data science, and IoT platforms and all. Yes, this will be a useful, and yeah, that way I can say. And that a lot of not only I'm precisely not know what sensors you are talking about, but there are many more sensors are used in IoT platforms.
Okay. So we have another question here. Regarding the Whirlpool slide, you have listed quantum computing as one of the emerging fields.
Right.
But won't advent of it break what we consider to be mature, like internet, especially cybersecurity?
No, I think I have mentioned in my slide, the quantum computing is not emerging, it's already emerged. Quantum computing is there from quite some time. And so it's in your question, you said it won't be invent. Listed quantum computing is one of the emerging fields. No, it's already emerged and it is already in use. Quantum computing. That's how your our big supercomputers and all are getting used in our ISRO and a lot of sectors, right, on those satellites projects and all. And break what we consider, no, I think no, that your fear is not true.
Yeah. In fact, quantum computing means is technological advancements is taking place at a very fast rate, and quantum computing is one of those latest features of technology,
But yeah,
improving
and
technology. Okay. Mm, okay, I think we have another one. Okay, it's about security. I think. Okay, you can take it up. Is
really,
our data really secure in clouds? As
it's
every
already answered by Dr.
yeah.
Shafin Malik has asked. Yes, fully secured. There is no doubt in that. With established cloud computers, if you go Amazon, Microsoft, or Google, will be fully secured. It's something like, no, I also host some cloud infrastructure. It's anybody can do that. Even I can do some cloud infrastructure. I opened it for my friends, and I can tell them that, no, you can host your. I can ask Dr. Sapan or Devashish or Anirban to host their personal files into my computer. That way, it will not be secured. I guarantee you that. But the established partner, those will be always secure.
Okay, I also have a related question. Sometimes it comes to my mind that
Mm-hmm.
nowadays we are all dependent. Means many of our files, even the those data and files related to this program, also are kept in my Google Drive and all.
Right.
So what happens if someday the whole Google Cloud thing or means crashes or
No, they
gets
cannot do that.
destroyed?
No,
Huh?
they cannot do that because
No, no,
you
not
know.
by their will, maybe by some say cyber attack or something like that.
Yeah. But
Yeah,
the thing is that those established platforms are much
yeah.
more secure, much more. It is more secure than your laptop or
Yeah.
wherever if you save it in your laptops or some hard drive, and whenever you connect the hard drive to internet, a
Mm.
software may come and ransom attack may come or some virus may come and corrupt them. But those
Mm.
platforms, because first of all, those will be encrypted and it will be stored and have lots of because I know that because we are dealing with these on regular basis, very regular basis on those river.
Mhm.
There will be
Yeah,
frequent compliance audits. It's not like they established it and then left it.
yeah,
There
yeah.
will be maintenance teams are there and frequent audits are there. And this goes directly. There will be some like no governmental audits also because
Yeah.
they're dealing with the public data. If
Yes,
they have a
yes.
government compliance also, they need to regulatory compliance are there. They need
Mm.
to fulfill and revisit it in every audit, in every quarter, half-yearly or yearly.
Yeah. Okay, so we have another relevant question. There are many apps. This is from Smita Das. There are many apps which ask for access to our personal photos, contacts, and it could not be installed if it is not allowed. So, are those apps safe enough that our personal data?
More of an help desk question, but even, as a statement warning, I may say that no, do not trust those. Even uh, when the reputed web sites, we say that if some apps or some all ask you for personal information, so do not trust them. They should be. I should suggest you to be very careful.
Uh, no, but most of the apps they ask us to allow this. No,
Access
even
photos.
yeah, even few days back, there's Arogya Setu app which was developed by Government
Those
of
are
India.
fine. Those are fine. Aragya Setu, those are reputed applications. They are
Yeah. So how does one trust means any features or why one should trust one app? Is there any criteria to find that?
no, you cannot find it like
In Play Store,
government
every
of India.
every app is available in Play Store, right?
Right.
So
No, they do not have that kind of thorough check. They have some sort,
mm,
but not full. To store in the app stores or Google this one, you should have some bare minimum criteria. That's how
Okay.
that some TikTok applications, right? Those been termed
Yeah.
it as unsecured. So,
Mm-hmm.
so you cannot have a control. Only what I do is I only trust the reputed application, which is the big names. But I guess it already been
Yeah.
certified by government of India. You can easily
Mm-hmm.
trust them, but not those other Chinese apps.
Yeah. Okay. And so I think there are no more questions. Okay. So
Okay,
it was
fine.
a wonderful session, and even the question answer session was also very elaborate. And I, on behalf of Department of Mathematics, I'd like to thank you very much again
Okay,
for being with us. So I hope that in future also we'll be able to get in touch with you.
sure, sure. And
Thank
please, if anybody wanted to know anything,
Yeah.
any research scholars or any students,
Yeah.
you can facilitate that with to me
Yeah.
and through my personal email IDs and all.
Okay. Okay.
Very happy to help anybody.
Okay, okay. Yeah, usually students ask on joining as intern means some sort of internship, which
Hmm.
programs in TCS. Do you have information, or how or can you say something how they can approach those? When
Yeah,
somebody
yeah.
who's doing say MCA or say MSc mathematics or computer, they are usually interested to join as interns.
There's a respective HR department who takes care
Yeah,
of the internships and all the recruitments and all. TCS is always giving privilege to the the newcomers, the
yeah,
young talent, because they have fresh minds and they
yeah.
are very innovative and all. So there is a respective HR department already doing that. I am since I am most of the time in away from India, so I am not in recruitment divisions so because whatever recruitment happens at TCS America or like other parts of the world are
Mhm.
happening in very limited way. But in India, they do a mass recruitment, 20,000, 30, 40,000 and all. My lot
Mhm.
of my friends go for recruitments and all in established universities and colleges.
Yeah,
But I do not have, I'm not engaged. TCS 4,000, there is just a respective division. I can
yeah,
always guide to the respective HR
yeah.
that I can do.
Okay, okay. Okay, acha, one last question. I think he's asking it several times. So let me.
Currency,
Uh,
cryptocurrency is one
cryptocurrency,
more thing.
anything about this?
Uh, I say no, probably we can cover it later. Cryptocurrency, bitcoins is a separate business process altogether. Okay.
Mhm.
So maybe in next some time to have another webinar, probably I can tell
Okay,
something about on it.
okay. So I request the participant to have a look elsewhere as of now.
Yeah,
So if we organize something on this, then he can
there will
join.
be a lot of resources. These are very
Yeah,
mature
yeah.
things and all having a lot of resources over the internet.
Yeah. Okay, then I am closing the broadcast, live broadcast now. Please stay back. We'll have a chat. I'm closing the broadcast, live broadcast now. Thank you, all the participants, and
Thank
feedback link
you.
is already provided. And in the video will remain in the in YouTube channel itself. So you can have a look. If you're not getting feedback link, you can have a look at the comment section of the video. After half an hour, you can have a look, and then you will get it. Okay, thank you. We'll join for the next session at 11:45. Thank you.
Thank you.